Right, so we're going to continue looking at transformations of sine and cosine. Today we'll look at amplitude and vertical shifts. Right, so first thing is, what is amplitude? Okay, amplitude basically means the height. Okay, you're finding the height of the wave. So if you drew in this kind of center line here, it would be how high up it goes off of it, which should be symmetrical with how low it goes. But that's the height. Right, now, because the amplitude is a height, what kind of number could you not have for height? Wouldn't make common sense. Yeah? Yeah, you couldn't have negatives. All right, so if I ask you what is the height, and I give you a problem, the answer should not be a negative. Okay, height is a distance. Distance is always positive. Okay, and this is what an amplitude change looks like. Changing the amplitude. Okay, with an amplitude change, you're not adding or subtracting with parentheses around the number and the x. You're putting a number in front. Okay, like that. That's an amplitude change. 3 sine x. So you multiply, and you put the number in front. Negative 2 cosine x. Okay, here there's two things happening. This 2 is going to do something, and the negative is also going to do something. We'll talk about that when we get to it. And here's another one. 1/2 sine x. Okay, now there's basically two things that can happen when we stick a number in front. We can either take the graph and stretch it, make it bigger, or we can compress it and make it smaller. Let's look at this one. Y equals 3 sine x. What do you think is going to happen if I put a 3 in front? Is that going to make the graph bigger, or is it going to compress it? What do you think? Yeah? Bigger. Yeah. Today it's pretty much common sense. If you put a big number in front, it's going to make the graph bigger. Put a small number in front, makes the graph smaller. What number do you think you have to be larger than in order to get bigger? There's one number you could put and it would stay the same, and then bigger than this, and it would get bigger.
1.
Yeah, bigger than 1, it's going to get bigger. Smaller than 1, like a fraction, it gets smaller. Let's just look at the difference between sine x and 3 sine x. Okay, so here is sine x and 3 sine x. Okay, so notice it's not moving left and right at all. It's basically just taking all these points and pulling them up and down, stretching it out. What do you think the effect would be on how we hear that? Like if I played the blue one versus the red one. So it would change like the pitch, like low pitch versus high pitch, like that. Okay, so it could change the pitch. What else can you change in a sound besides the pitch? Yeah? Yeah, how loud it is. So it's going to change one of those two things. Let's just try it. So here's a sound. Let me turn it up a little. Okay, at 1,000 hertz. Now if I stretch it vertically, what happened? Did it change the pitch or did it change the volume? Change the volume. So you can't hear it once you make it flat. All right, so this has an effect on volume. That's how you hear it. Okay, if I tried 1/2, same idea, except instead of taking that graph and having it stretch, it's going to compress. All right, so if I put in 1/2. Okay, there's the original. And there's the new one. Now it's half as high. Okay, so any question on what an amplitude change does?
What if you use a negative?
A negative, let's see if you can tell me what happens. I'm going to graph negative sine x. So there's the original. It flipped it. Yeah. So basically what happened is, you can kind of think of this as having -1 in front. If I just put a negative, I'm not changing the height. I could if I put it like a -2. But if I just put a negative without any other number, it takes all the highest points, makes them the lowest, takes the lowest and makes them the highest. Basically flips everything. But if I were to just show someone this picture, they wouldn't be able to tell, did he do a phase shift where he just took the red one and maybe moved it to the right, or did he flip it? You can't tell by looking at it. Right? But I could get the exact same picture by doing this. Can't tell the difference between those two. They're the exact same graph, but very, very different ways in how I graph them. Yeah.
Oh, I was going to ask, like, does the line ever go straight or
no? No, not unless it was like 0. Yeah. Not unless it was flat, but then if I did that, it wouldn't be a wave anymore.
So we're not going to have to graph 0?
No. No, you'll never have a straight line. All right. So if I ask you on any of these functions, okay, to find the amplitude, take the number in front and take the absolute value of it. So what's the amplitude of this first graph, 3 sine x? 3. What's the amplitude of -2 cosine x? 2. And the amplitude of 1/2 sine x? Now, what if I did this? What's the amplitude now? Still 1/2. This negative doesn't affect the amplitude. It's going to affect the picture when I sketch it, but it's not going to affect the amplitude. It'll cause it to flip. Okay. Questions on that? All right. So amplitude is always positive, okay, because it's measuring a height. And we talked about when does it stretch and when does it compress. Well, if the number in front, if you take the absolute value of it and it's bigger than 1, that's going to cause it to stretch. Okay, if you take the absolute value of the number and it comes out less than 1, that's going to cause it to compress. Okay, so things that would stretch it, a number like 1.5 would stretch it a little bit. Okay, 2, -3. That would stretch it and it would flip it, but the 3 would stretch it. Numbers that would compress it, 1/3, -0.5, 1/5. All those things I just said would compress it. All right, so any questions on when it stretches or when it compresses? That's all you really need, what I just underlined. And this is all along the y-axis. We're not stretching or compressing along the x-axis. When we do that, we get all kinds of different effects that happen with the sound. We're going to do that tomorrow. Okay, does everybody have that? All right. So just like every other graph, first thing we got to do, find those 5 key points. All right? We already know where it starts. We're going to figure out where it ends up. If we're changing the height, okay, what values does that affect? X's or Y's? Y's. Okay. So what values are going to stay the same? X's. All right. So when you stretch something vertically, you're changing it on the y-axis. You're not stretching it left and right. We're stretching it up and down. Okay. So the Y's are going to change. X's stay the same. Okay, and whenever the x's stay the same, that makes life a lot easier. Okay, x's are those numbers we don't like to work with. Pi over 2, pi, 3 pi over 2, and 2 pi. All the fractions with pi. We're not going to have to work with any of them today. Okay, we're going to be working with the other side, the y values. Well, the y's are extremely easy. They're ones, zeros, and negative ones. So all we have to do today is arithmetic with 1, 0, and negative 1. Much, much easier arithmetic than yesterday. Okay, and for a vertical stretch, or amplitude change, all we got to do is take the old y values and multiply them by whatever the number is in front. Okay, a. Don't take the absolute value of it here. If it's a negative 2 in front, use the negative 2. If it's a positive 3, use positive 3. Do not take the absolute value when you're graphing. Okay? Only time you take the absolute value is if I specifically ask you, what is the height of this function? Height has to be positive. All right, so let's try an example. All right, so the first graph here says y equals 3 cosine x. Okay, now we know two transformations. We know phase shift, and we know amplitude change, or vertical stretch. Same thing. Which transformation is this?
Amplitude.
Yep, it's amplitude. And how do you know?
It doesn't add or subtract.
It doesn't add or subtract where?
The x.
Yeah, to the x in parentheses. You don't have a parentheses and then plus or minus. Okay, that would be a phase shift. Okay, number in front, amplitude change. All right, for an amplitude change, what column stays the same? X's stay the same. So I'm going to copy those down. Kobe, can you remind me what my x's are? For cosine? Or for sine, they're the same. Yeah, the x's are the same for sine. Yep, 0. Yep. 2 pi. These are going to be the x's for every problem we do today. Every single problem in the homework. These never change. Okay, for today. Okay, now we need the new y values. Brandon, what are the original y's for cosine?
They're 1, 0, negative 1, 0, 1.
I'll say it again. Don't make the mistake of copying down the ones for sine. This is not a sine problem. Cosine. All right. Now we take all the old y values and multiply them by the number in front. Okay, triple them. All right, so Cooper, can you give me my new y values?
3, 0, negative 3, 0, and 3.
That's it. That's the whole table. All right. So you get 10 points just for that table part. Okay, so hopefully you found the arithmetic a lot easier than yesterday. And now the last step, we graph it. Okay, I'm going to label my x-axis. And you do need to do that on the test. Okay, make sure you label it. Now there's a couple ways I could do it. One way to do this is just put 3 here and put negative 3 there. I'm just going to scale my axis. Instead of go by 1s, I'll go by 3s. Okay. If I wanted, I could draw in all the lines and label them 1, 2, 3, but you can do it just like that too. All right, so we're good. 0, 3, pi over 2, 0, pi at negative 3, back to 0, back to 3. And that's it. That's our graph. Okay, any questions on that? Yeah.
Can you just go back up so I can the problem?
Oh, the original problem?
Yeah.
3 cosine x. What's nice about doing it this way is, say I asked you to graph this. You could reuse the same picture. All you'd have to do is go like this. Now you just graph this one, okay? Just by changing the scale. So as we go through it, you might say, well, how come all your pictures look the same? Well, they look the same because I'm going to change the scale on my axes. I'm not going to draw it bigger or smaller. Just going to change the scale. Let me put it back the way we had it. Okay. Questions on that? All right. So bigger number in front made the graph bigger, 3 times as high as it used to be. Okay, this time we have 1/2 in front. Is this going to stretch or compress? Yeah, it's going to shrink it. It's going to compress it. Okay, before I even graph it, what if I asked you just what's the amplitude of this function? 1/2. Okay, what if I threw a negative in front? Still 1/2. Negative is going to flip it, but it's not going to change the height. All right, so we know it's a vertical stretch. Keep your x's the same. And if you want to label them on your graph at the same time, we could do that. Okay, so now we're working with sine. Okay, Tyler, what are my y values for sine?
0, 1, 0, -1, 0.
All right, 0, 1, 0, -1, 0. Oops. And let's put those off to the right because we're going to do something to them. All right. How about Sarah? What am I going to do to all those y values? Yeah, just take half of them. That's it. Okay, on the test, sometimes I see all kinds of things where people try to add 1/2 to all the x's or subtract a half from all the x's, and it's just the wrong thing to do. Okay, number in front, multiply the y's by that number in front. And that's it. All right, so the highest I need to go is 1/2, and the lowest is -1/2. So I'm just going to set up my axis that way. Right, and we're at 0, 1/2, 0, -1/2, back to 0. Okay, any questions on that one? All right, and last one. Okay, this one doesn't really change the amplitude because there's not a number in front, just a minus sign. But technically there is a number. Okay? Same number you have in front of x here. What is it? 1, -1, yeah. Okay, you could think of it that way. So the amplitude of this function when we're done is still 1. Okay? But the negative is going to cause everything to flip. Okay, we already looked at a picture of it. Okay, so keep our x's the same. And now this one, let's see if we can do it in our head. Okay. All the y values are going to be multiplied by -1. So just take every y value and make it the opposite. Okay, so anyone think they could tell me my final y values? Yep, go ahead, Brandon.
-1, 0, 1, 0, -1.
Yep. That's it. Okay, so 10 points for that table. And now we do our sketch for 2 points. This time you don't need to change the scale at all. 1 to -1. That's as high and low as you go. Okay, label your x's. And put in your points. So -1, 0, 1, 0, -1. So you can see now instead of being that V shape we normally get with cosine, it's flipped over. So now it looks more like that. And if it was going to continue, you'd go on like that. Right, so any questions on amplitude change, vertical stretch? All right, so the last one we'll finish up with is a vertical shift. Vertical shift looks like that. It can be sine or cosine. Except this one has plus or minus. We're not multiplying this time. Plus or minus d. I just picked d. Now I thought phase shift also had plus or minus a number. Question?
Yeah, you're wrong. No.
You have a mistake?
No, wait, can you go back to the...
Yeah, let's take a look.
The first one's supposed to be 0. Yeah, how do you multiply -1 by 0 and get -1? You get 0 for your first y.
It's cosine.
Cosine. So the first y value is not 0 for cosine.
Okay, I'm looking at the wrong chart.
Sine, yeah, I know.
She was like, you're wrong. I said, don't say that.
Well, I am. Sometimes I am, but on this one, I don't think I am.
Yeah, so he's wrong.
Nice job,
All right, so what's the difference here between this and a phase shift? Phase shift has plus or minus a number at the end, just like this one. But one kind of small but really, really important difference. Yeah?
It's not on the inside of the parentheses.
Right, it's not like this. That's a phase shift. That's a vertical shift. Okay, and a vertical shift does exactly what you would think. It's going to shift up or down. One of these does up, and the other one does down. Okay, any thoughts which one is going to shift up and which one shifts down if life was nice? Yeah?
+2 goes up, and then -3 goes down.
Yeah. Plus is going to shift up, minus is going to shift down. All right, so when you're doing amplitude change and vertical stretch, amplitude change and vertical shift, you don't do the opposite. Okay, you're not going to be doing the opposite. A lot of people end up doing that because they get phase shift stuck in their head and they see +2 and they're like, oh, wait a minute, I got to do the opposite. No, not for this. Okay, and I'm going to write that down in a second. Up is positive, down is negative. Don't reverse it. Okay, so this step we've seen so far with every type. We're going to find where the 5 key points move to. Something's going to change, something's going to stay the same. What is going to stay the same if you're shifting up or shifting down?
X.
The what?
X value.
The x values are going to stay the same. We're shifting up and down. That affects y values. We are not shifting left and right. That was yesterday. Okay, so again, what's nice? X's are the ones we don't like to work with. Those are all the fractions with pi. You're not going to have to work with them. Okay? All you're going to be working with is 1s, 0s, and -1s. Okay, and this time, you take the number that's at the end, and you do that to all the original y values. Okay, so if I was graphing sine of x +2, I would take all the y values for sine, and I would add 2. Right? If I was graphing the one on the bottom, cosine of x -3, I'd copy the x's down, they stay the same. And to get my new y values, I would subtract 3 from all the originals. Right? So you do exactly what you see right here. Don't do the opposite. Okay, does everybody have what's on the left? All right, so we'll just do 2 vertical shifts. We'll do one up, one down. And maybe we'll do one sine and one of cosine. All right, so here's y equals sine of x +2. Okay, on the test, first thing I would do is look at that and write down what it is. Is it a phase shift? Is it an amplitude change? Is it a vertical shift? What type is this one? Yep, it's a vertical shift. And can you just tell me how you know that? Yeah, we're adding or subtracting, and you don't have parentheses. What if I did this, though? Can't be both. No, it's one or the other. That's like, yeah. It's still a vertical shift. The parentheses have to be around the letter and the number. Okay, let's see if people were listening. What if I did that? It's still the same thing. The only way I could make it a phase shift is if I did that. And I am not going to give you a phase shift like that. Only phase shift I'm going to give you is either going to have a pi here, a pi over 2, or a pi over 4. Okay, just like in the homework. Right? So on the test, I get a lot of people doing this as a phase shift, and they try to subtract 2 from all the x's, and they get totally messed up. So that's a vertical shift. Okay, vertical shift. Amanda, what stays the same? X's or Y's? Yep, X's stay the same. Okay, take all the original Y's, which, let's make sure we know those, 'cause a little confusion here last time. Emily, what's my original Y's for sine?
It's 0, 1, 0, -1, 0.
Yeah. Okay, so those are your Y values for sine. Okay, Leah, what do I do to all these values for a vertical shift?
Add 2 to that.
Yeah, I'm gonna just add 2. So just add 2. So 2, 3, 2, 1, 2. Okay, any questions on how we got the table? All right, now your last step, you can make your sketch. This time, I don't need any negative values on the y-axis, so I'm just going to draw the positive part. 1, 2, 3. Do I need to label my x-axis, or can I just leave it like that? You have to label it. If you don't, you're going to lose a point. Every problem tonight in the homework, you can label it just like that. And now fill in our values. So we're at 2, 3, back to 2. 3 pi over 2, we're at 1. And back to 2. All right, any question on that graph? What's the amplitude of that graph? I could ask that. What's the amplitude?
3.
Nope, it's not 3. I see why you'd say 3, because 3 is the highest point it hits, but it's not the height of the wave. 1. It's sine of x. What did I put? Plus 2 at the end? What number is in front of sine? We didn't write it, but if you want to pretend there's a 1 there. Okay, we didn't stick a number in front of sine. Okay, other way you can look at it, put in the center line. How high above the center line does it go? 1. 1 unit above it, 1 unit below it. What if I did this? That would be tough. All kinds of things happening there. But what's the amplitude? 4. What's the pi over 2 do? I like the direction you're thinking, but in this case, that's a phase shift, right? So phase shift always does the opposite. So in this case, plus pi over 2 moves it left. What about the minus 5?
That makes it go
Up and down, and this one is
down.
All right? So make sure you know what each part does. So if I ask you for amplitude, you focus on that. and ignore everything else. These have nothing to do with amplitude, just that one.
So are there going to be problems like this?
Yeah, I'm not going to ask you to graph something like this, but I might give you this and just ask you, what's the amplitude? That's all. Okay, in pre-cal, we graph things like this. And you guys could probably do it too. It's not any harder. You just do it one step at a time. Graph the phase shift first, then you graph this, then you graph that. So it's like doing 3 problems, but you do it one step at a time. It takes longer. Right, so all of our problems only have one thing in them. They shift up or they shift down, that's it. Shift left, shift right, that's it. This one is a shift down. All right, so take 2 minutes, see if you can get the table. If you can't get the graph because you don't have a grid, that's fine. Just see if you can make the table. Okay, and then we'll go over it, and that'll be it. All right, so most people had the right idea that it's a vertical shift. Okay, so it's going to go down 5. So x's stay the same. Okay, at least if you know what stays the same, you can get 5 points just for that. Okay, even if you don't know how to get the y's. Okay, so there's my x's. I'm going to take all the original y's. Make sure you're copying them from the cosine table. What am I going to do to all those?
Subtract 5.
Yeah, subtract 5 from all of them. Right, so we get 1 minus 5 is -4. 0 minus 5? Next one? Yep. -4. Okay, this time because your y-axis is completely negative, there's really no need to sketch anything in the positive part. Just label your negatives. Okay, now x-axis, you can label down here because your graph is going to be even further down. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, so we're at -4, -5, -6, -4, -5. And make your sketch. Wait, am I off by 1?
Yeah.
That's okay. Oh no. Can't do that. We'll just move around. Okay, when you do it, it's going to be a little easier to line up because I've got the grids drawn on paper, so it'll be easier and it won't be as big. There's your sketch. Okay. Questions on that? All right, so that's vertical shift. So now we know how to do phase shift, amplitude change, vertical shift. That only leaves 1 left for tomorrow. Right, so the homework tonight, it's same idea as last night. Okay, worksheet, 5 questions.